So what would this mean now? So I got my suction, my nice cool gas coming back. Superheat is good. What does superheat good mean? Nothing to me. Superheat is 10 degrees, 20 degrees, 30 degrees. Just remember that. When you say superheat good, that means nothing to me. I need the facts. And that's what you need to do, is get the facts. So you understand, is it too high of superheat, too low of superheat? So we have this cool gas coming back to that first component, a strainer. What happens if you don't use nitrogen while you're brazing? Or you're not purging while you're brazing? What happens inside the... It oxidizes. And where does that oxidation go? Goes through the system. Then it goes to that strainer. And this strainer is to protect the compressor. But what happens if that strainer gets real clogged up now? Drops your pressure. What's the motor not getting? Cooling. So what happens? So on this side, right up to this point, we got a lot of cooling happening. We got the right amount of cooling. And then what's happening to the motor and then inside here? So it's not getting the cooling. So now this motor, the stator, is generating a lot of heat. And it's going to generate more heat, and then this body here is going to heat up even more. And so it's a bad effect that's going to happen. Okay? So you always want to make sure to check that. You'll look at Carlisle, you'll look at Bitzer, they'll have strainers there as well. Because they're worried about us as technicians cutting the pipe and dropping, like shaving it. We need a ream pipe. So what I mean by reamer, after you cut it, you take a reamer and then you'll shave it down so it's the same, the pipe is the same through. But a lot of times that could fall in there. Like Roman showed someone cutting with Sawzall, and you see all those little copper shavings. So they could fill that right up. Well, we're protecting it so it doesn't go in here, because if it gets in here, a lot of times it's contamination from us. But if it gets in here, you get a spot burn, or you'll get electrical failure, because this stator here is protected. It has coating on it. It has insulation on it. But if you start putting sharp metal objects in there and contamination in there, every time to start up, there's always some sort of force inside there. And so if there's any vibration at all, it'll work its way in. This is a 3-phase compressor. You always want to, before you even get into tear down, and when I walk through the steps, is you always want to do it safely. First step is locking out electrical power. But that electrical power comes to the stator, it generates energy, and it spins that rotor. And when that rotor starts to spin, it starts to move these pistons up and down just like this. Oh, Chad, you crushed it, buddy. Yeah. So what happens, it takes this suction gas, like this nice cool gas, this low pressure, cool gas coming down into here, and as it compresses, this piston here, it'll just nicely come down at 1750 RPMs, if that's 60 hertz, or 14, I think it's 1450 at 50 hertz. And at this bottom dead center, all this gas will come into here. Below here in this valve plate, there's going to be a suction valve. As that opens up, depending on how far it goes down, so it pulls down, it'll open up, it'll fill this chamber right up. And then when it's bottom dead center, then it'll continue to push that gas up. And as it starts to compress that gas, it builds pressure, it builds temperature. And then you get all the way up, and you'll hit a point where it'll open the discus puck that's not here, or the reed valve that would be there, depending on the compressor manufacturer. And as it squishes, it'll open it up, and then it pushes the discharge up over here. This here is a full discharge up here, and it'll go out here. This is not a standard fixed compressor. This is a modulo compressor, and what it does, it has these 3 tubes in